I am Gina Van Pelt, and today we will be talking about typhoid fever and all the aspects of this fever. My microbiology group is also composed by Jessica McGrill and Victoria Arckerman. Please enjoy the presentation. The bacteria that causes typhoid fever is called Salmonella typhi. This bacteria is a gram-negative bacteria and belongs to a group of bacteria that do not retain the crystal violet stain used in the grain staining method, where a violet color stain is placed upon the bacteria. After that, we can see the bacteria differentiation through a microscope. In this slide, we can see a color-enhanced scanning electron micrograph showing Salmonella typhi in red invading cultured human cells. After staining with crystal violet, an alcohol wash is applied which decolorizes the bacteria, showing the peptidoglycan layer, and this is too thin to retain the stain and enabling identification. This is Hans Christian J. Graham. He was born in September 13, 1853 and passed away in November 1938. He was a Danish bacteriologist, noted for his development of the grain stain method that we just used on the bacteria differentiation. The bacteria Salmonella typhi is a rod-shaped bacteria forming a slender bacillus we see here in a green shape. It is also a prokaryotic cell. In this picture we see the gram-negative bacteria Salmonella typhi that has a thin layer of cell wall called peptidoglycan between an inner cytoplasmatic cell membrane and also a bacterial outer membrane. Gram-negative bacteria have bacterial outer membrane vesicles, OMVs, for trafficking bacterial biochemicals to target cells in their environment. OMVs also initiates disease process in their host. Transmission electron micrograph of outer membrane vesicles, OMV, released by human pathogen Salmonella. Here we see they were proposed to blow off from large bacterial periplasmic protrusions called periplasmic organelles, PO, with the help of bubble tube-like shape. This allows membrane vesicle trafficking of OMVs from gram-negative bacteria to dock on host epithelial cell membrane or microvilli on the bottom of the screen, translocate signal molecules from pathogen to host cells. Here we find a unique factor present in Salmonella typhi. The typhoid toxin is a unique virulence factor of S. typhi, and it reproduces many of the acute symptoms of typhoid fever. Intracellular pathogens are responsible for much of the worldwide mortality due to infectious disease. To colonize their hosts successfully, pathogens must sense their environment and regulate virulence gene expression appropriately. Accordingly, on entry into mammalian cells, the facultative intracellular bacteria pathogen Salmonella typhi remodels its transcriptional program by activating the master virulence factor of typhoid toxin. These are the sources used in etiology. Next, we will watch Jessica McGreal talking about reservoir signs and symptoms, followed by Victoria Arckerman talking about transmission, treatment, and prevention. Thank you so much for watching.
Okay, hi, my name is Victoria Ackerman, and I'm doing the last part of the disease presentation. So let's get started. I used two different sources. First, I got most of my information from the CDC website. I highly recommend you go there and read about typhoid fever. I also got some information from the Mayo Clinic website. Both are great sources, and I recommend looking up any information you're curious about on either site. Typhoid fever is a life-threatening illness caused by the bacterium Salmonella typhi. It remains a serious health threat in the developing world, especially for children. People are the only source of this disease. This is not the same type of bacteria that can cause salmonella food poisoning, but the two are related. Salmonella typhi is a related bacterium that usually causes a less severe illness. Persons with typhoid fever carry the bacteria in their bloodstream and intestinal tract. In addition, a small number of persons, called carriers, recover from the typhoid fever but continue to carry the bacteria in their stool, often for years and even after treatment. You can get typhoid fever if you eat food or drink beverages that have been handled by a person who is shedding Salmonella typhi, or if sewage contaminated with Salmonella typhi bacteria gets into the water you use for drinking or washing food. The CDC recommends either cooking your food or boiling it. Never eat anything raw. Also, they tell travelers to never eat anything from street vendors, and to always peel your own fruit after washing your hands. Never eat anything that has already been peeled. Typhoid fever is more common in areas of the world where hand washing is less frequent and water is likely to be contaminated with sewage. The majority of people in industrialized countries pick up typhoid bacteria while traveling and spread it to others through fecal-oral route. You can contract the infection if you eat food handled by someone with typhoid fever who isn't washed carefully after using the toilet. Once Salmonella typhi bacteria are eaten or drunk, they multiply and spread into the bloodstream. The body reacts with fever and other signs and symptoms. Now let's talk about treatment, prevention, and control. Typhoid fever can be prevented and can usually be treated with antibiotics. Most people with typhoid fever feel better within a few days of starting antibiotics treatment, although a small number of them may die of complications. If you are planning to travel outside the United States, you should know about typhoid fever and what steps you can take to protect yourself. There are two basic actions that can protect you from typhoid fever. The first is avoiding risky foods and drink. Second, get vaccinated against typhoid fever. There are two types of vaccinations in the United States. Vaccines usually are reserved for those who may be exposed to the disease or are traveling to areas where typhoid fever is common. Each vaccine needs to be taken at least 1 to 2 weeks before going on your trip. The vaccine can last for years. Vaccines against typhoid fever are available, but they are only partially effective. If you have been vaccinated, you can ask your doctor for a booster. The first vaccine is TY21A. It is an artificial immunity, which means it protects from infection obtained through medical procedures. It is one capsule that can be taken orally. You need to take it 4 times a day or 2 days, one week prior to the trip. This vaccine can last for 6 years. It does need a booster every 5 years. The second vaccine is VICPS. It is also an artificial immunity. It is an injection, but you only need one. It has to be given 2 weeks prior to the trip. It can last for 2 years, and it needs a booster every 2 years as well. In the United States, it's estimated that approximately 5,700 cases occur annually. Most cases, up to 75%, are acquired while traveling internationally. Typhoid fever is still common in the developing world, where it affects about 21.5 million persons each year. So please be safe while traveling. Be sure to get the proper vaccines before traveling internationally, and bring your own drinking water or buy bottled water. Thank you for watching.